Welcome to this screencast on energy at the University of Hawaii. Today I'm happy to tell you that I'm with Eileen Peppard from Sea Grant.
Yes.
And she'll be telling you about some really cool projects that are going on. And the goal of this is to give you more insight into the stuff that's going on at Hawaii and the opportunities that people have who have a background both in software development and energy at the same time. That's what we're trying to pitch them to do.
Mm-hmm.
Okay? So, Eileen, how are you doing?
Good. How are you?
I'm pretty good. So, Kuykendall Hall renovation, what's this about?
Okay, well, it's part of the Commercial Building Partnership, and it's one of 3 programs in the United States right now. The other 2 are the New York Times building and the NASA Ames building in California. So
New York Times, NASA Ames,
and Kuykendall.
And Kuykendall.
You know?
Who would have thought,
I know,
if you look at Kuykendall, that it would be in such an esteemed company, building-wise, right?
So we have the best...
From the sublime to the ridiculous is what I'd call it.
The best building scientists at the Lawrence Berkeley Lab helping us out.
Okay.
So the guy with the crazy hair he's
on the phone.
Yeah,
it looks like in this picture.
He is. He's an engineer there. Then the guy on the left is with what we call the M&V, the Measurement and Verification Team. So he's a consultant with Quest.
Okay.
And then the guy on the right is one of the local architects.
Okay.
So, the idea is to have the scientists help the local team actually improve their design.
Oh, okay.
So they're putting the whole building into energy modeling software. And they come up with ideas for how they want to retrofit it, and then they run the test through the software to figure out if it's going to work.
Okay. Okay.
So it's to predict it. And then after the retrofit, we'll continue monitoring, and we'll see if it performs as expected.
Right. So I've heard a little bit about this project. So basically this is supposed to be energy neutral.
Yeah, we're trying to go for net zero, but we don't know if we're going to make it quite there.
Okay.
So right now we're sub-metering all of the circuits on the building to get a baseline what's going on now.
Oh, that's good.
The idea is that they're going to be retrofitting, making it natural ventilation with some dehumidification. But with the windows open, then you have issues with noise and other problems. So they're trying to mitigate that.
Okay. And so where is this data going that you're going to be collecting?
Well, all the data, it's on the internet now, and then they extract it over there in California and put it into the modeling software.
Okay.
And we have you'll say...
So you're familiar with Watt Depot, of course, and so I'm wondering, is there an opportunity for someone with Watt Depot skills to get the data out of the building now and do some things with it?
Oh, yeah.
Very good.
You guys could play with it, and I've got other stuff that I'm dying for somebody to help analyze data.
Great.
How do I go? Okay. Yeah. So, this is one of the consultants on the left there with me. So we have current transducers on these circuits, and then the data is wirelessly transmitted to a laptop in Kuykendall.
Okay.
And on the right, we're just installing some of the sensors up in the ceiling.
So when you say current transducer, CT is placed on all circuits. Are circuits at the floor level, room level, sub-room level? What does that mean, really?
They're different circuits for different parts of the building, and then there's the classroom building, there's the tower, and then they do have things separately. I think the lights on each floor are on separate circuits.
It's a mess.
Yeah, it is.
Okay, right.
Luckily, I'm not analyzing that data. That's what these expensive consultants are for.
Okay.
So this is the mesh network on the left. So you can see that they're all communicating. The neat thing about it is that each sensor will have multiple routes that it can go to send its message, but it only uses one. It uses whatever it thinks is the strongest. But the nice thing is if you lose a node, it will find another node that it can communicate with. So you're not losing a lot of data when one node goes down. Right. And then on the right, there's certain things that we don't have on the wireless. So we have this. This is logging the plug load for this window air conditioning unit because it's not on the
sensor net. So the wireless sensor network is actually for environmental data.
And the circuits that are being monitored. So it's both.
Oh, so what we saw before was the whole building load down in the basement
Yeah.
with you?
Yeah.
I see.
So
Okay.
that was various loads, and then on the right were environmental sensors that we were installing.
I see.
Okay, so but the problem is we don't have the ACs on a separate circuit.
Right.
So if we want to see how much ACs are versus other plug loads,
What are you going to do about that?
well, we have this device here, so this AC is plugged into it.
Oh, okay.
And it's not like a kilowatt meter, which just tallies the total use over that time. This is logging it so we know when it came on, when it came off. So it's time stamped. So we can look at the duty cycle, how long it's on, how long it's off for.
Yeah. It's
all
time
that.
stamped data
Yeah,
as opposed
yeah,
to
yeah.
just, okay. Yeah,
so
sure.
the kilowatt meter just gives you a total for
Right.
the time
There's no
that you have it
timestamps.
plugged in.
And can you connect that to the internet, that little
So
box
no,
there?
this one we don't have wirelessly, so
Come
we have to
on,
download
Eileen.
it every month.
Jeez. Oh,
So every
God,
month,
that's terrible.
Every month, Trevor has to go through, download certain sensors, and then put the data up on the website.
Okay, note to self.
Note to self.
Maybe not myself, but some other self. There's a group in town that's creating this like maker space kind of thing, and one of the things they like to do is create Arduino devices.
Mm-hmm.
So I'm wondering if one of those people might want to build a little device that can make this wireless. Wouldn't that be
Yes.
cool?
And there was a guy at the Lawrence Berkeley Lab. I listened to a seminar. He made
Yeah.
one, but it's
Yeah.
not commercial. He made it because it wasn't commercially available.
I know, and it's
so
not
he
hard.
made his own, but he did say like, "Oh yeah, well the first one kind of melted."
Right.
But he got it to work eventually.
But what I'm saying is that this stuff is not that complicated
Yeah.
to build actually in this day and age.
It's just a
and
matter
so
of
it's kind of a
insert-
hobby project.
right.
And so for example, if students wanted to combine some software skills, learn a little bit, like a tiny little bit about hardware, that would be a project for them.
Yeah.
Is to
Yeah.
buy some Arduino. It costs $100 probably of hardware. You can buy these little Arduino kits that have a wireless device associated with it that's built in, and all the libraries for doing HTTP communication, and you hook one of these things up, and because I assume that's a USB cable, right? To the
Yeah.
So
Yeah.
shouldn't long weekend is what
Yes.
I'm going to call it.
Yes, but the Lawrence Berkeley guy said it cost him about $70 or $80 to make his own.
Yeah, that's what I figured. $100, something
Yeah.
like that. Yeah.
Okay. So we also have a weather station on top of Kuykendall, and that
Nice.
is hooked up to the internet and just constantly streaming data.
Nice.
And if it doesn't communicate, we get an email saying that it's down. But usually we get an email quickly after that saying it's back.
Right.
So that's
Does this
pretty
hook up
neat.
to the UH network? Is that what you have, or where's it hooking?
It's feeding into, I think it's an FTP site for the consultants to be able to collect the data.
Okay.
Or whatever. I don't know.
Yeah,
I need somebody like you guys to work with me because I
there are
don't
a
know
lot
this
of
stuff.
opportunity. Look at all the opportunities.
Yes,
I'm
yeah.
seeing them on every
Yeah,
slide.
this is,
Okay.
what do you call it? Job security, when people like me can barely turn on a computer.
Okay.
So, there we go.
But that's cool stuff there.
And the data from this has already affected the design of
Wow.
the building.
Really?
Mm-hmm.
In what way?
Well, because they didn't have good data that was right there. And
Did they find that it's really hotter than they thought, or colder than they thought, or windier than they
Probably just better wind data, because the wind, they were dealing with wind data from the airport.
Oh, right. And for ventilation, that's
Yeah.
really key
Yeah.
stuff. I see.
Yeah.
Okay.
And they did model this whole building and the buildings near it and put it into a wind tunnel in California and tested it in the wind tunnel.
Nice. Okay.
Okay, this isn't, you guys wouldn't be interested in that, sorry.
Okay.
Okay, so we are doing a home that was built, it's a model home called the New Hawaiian Home, and
Good.
somebody's living in it now. But it's built with locally available materials, but the best efficiency that they could get, or at least that they could get donated. And we're comparing these to other homes that we're monitoring.
Wow.
And this is really cool because
Yeah.
they have a radiant barrier in the attic. They have
I see solar panels.
Yeah, they have solar panels. They have hot water. They do a little bit of water collection off of it.
Rain catchment.
Yeah, but only a
Nice.
small amount. It's token.
Yeah.
But they have a whole house fan. They do have ACs, but it really is designed to be cool. I went into this house when it had been closed, completely sealed up for a week, and I got there, in the middle of the day, and it wasn't hot in there.
Nice.
I mean, it was
Yeah,
not fresh, but it
Right,
wasn't
right,
hot.
right.
So it's really well designed, high performance windows. It's awesome. So we really want to get some baseline data on that.
Great.
And see how it compares to other homes.
Fascinating.
So we did the works on this house. We did a blower door testing, see how leaky it was, and we're sub-metering circuits, and we're logging temperatures, the works. And so we're going to be comparing that data to these not-so-efficient homes that are military homes.
Right.
We do a general audit on them, looking at all the appliances, and we install sub-metering, and we check. The fridge isn't on its own, so we use a kilowatt meter for the fridge. So we're trying to look through. We have reams and reams of data, and this is the challenging part for me, is to try to get through all of this.
Right. Good.
Advanced auditing, we do the blower door testing, duct blasting. So this is checking to see how leaky the ducts for the air conditioning system are. We have an...
and are they leaky in general?
Yeah.
Yes.
Yeah.
Okay.
Yeah. This is an infrared camera, so we can actually shoot it and see where there's insulation missing in the ceiling. It's amazing. And you can see when you're running the blower door and you have air like getting sucked out of the house, you can see where it's leaking through
So
spots.
interesting. Yeah.
It's really an amazing device. It's creepy because you can walk across the carpet and you can see your footprints.
Oh, wow.
Yeah.
Wow.
Yeah.
Like Hawaii 5.0 or something. You can have it in an episode.
I'll tell you what.
Yeah.
And then once you see that the ductwork is leaky, we can use this device to go around and see, well, where is the leak closest to? Because if there's one big leak, you'll be able to measure and see differences between in the house and in the duct while it's running and see where so you know where to start searching.
Right.
And that's the blower door they're working on there. So then we also have here our temperatures. This was interesting. So this is mapping out, this is the energy being used by the air conditioner, and this is the temperatures inside the house, the pink and the blue, and this is outside the house. Okay, they went away for Thanksgiving, so they turned the AC off, which was very good of them. And then you can just see how the temperature floated over that time. Right. So it was very interesting to have one house where they did that, because most of the time they're occupied the whole time. Yeah. So, but a lot of this data was hard for us to. So I think your software might help us. This energy was logged in 1 minute data, but this was 5 minute data. Right. And to get it on the same.
Hassles.
Yeah. Some hassles. So.
Yeah. Okay.
I've got more. I got a better slide than that one.
Yeah.
Okay, one of the things we've looked at was GIS and overlaying energy use. So the more intensive energy using houses are in the darker colors. But the problem is, the idea was that depending on the orientation of the house, you might see more heat gain, and then the AC has to run longer. But because people's habits and other variables come in, we can't see it.
Right.
It's just not going to be there.
Right.
They might, there are too many variables, so that so far hasn't shown us anything.
Right.
So this is just the Excel sheet with some power data on it. We normalize, if we've only done 28 days or we did 35 days, we change it all to be a 30-day period, so that matches the person's bill, and they get an idea of, it makes more sense to them.
Sure, yeah.
And we calculate things like how many hours was the dryer running, so we can tell them that this is how much energy used and that's how many hours you were running it.
Okay.
Then there's weird things like the hot water heater. It usually runs 4 kilowatts, so 4,000 watts, and we have numbers here that are around 53. Well, the solar water heating pump was on the same circuit. So we had to go and subtract that out from the total. So we have some monkeying around with the data.
This is, and I just from working with you before, I can say that it's an interesting situation in which getting the numbers is just the first of a very long process of understanding what the numbers mean, how they tie to the actual devices in the house, and if the numbers are actually accurate, and if the system really collected the correct stuff, and it's really an amazing process of working with this kind of quote unquote real data, and just figuring out what can I trust, and how do I interpret it, and so forth.
And, and I get an Excel sheet with 50,000 lines of data. You can't check all of that, but then I graph it. And I know immediately when something's wrong. I can look at this data's wrong. This shouldn't be.
Right.
So it's very helpful to graph it out.
Yeah. And the nice thing is that if you can tell immediately, what that indicates is there's probably some fairly easy computational check You know, like you're seeing a spike or something, you know. And so that's the kind of stuff that you could engineer into the software so that you wouldn't even have to look at it. You know, you could just run a program, it'll tell you, well, look at this data, this data, this data, because, you know, there's something like that going on. Right, so disaggregation, the holy grail of energy
so this
analysis.
is just kind of giving you an idea of how I break it up so that we can see what's going on. So important things is how many kilowatt hours per month each of these devices uses. But of course, most residents really don't know what a kilowatt hour. They don't know what their bill would normally be, so I change it into dollars for them. And I
with
also,
normalized dollars, or I mean the cost for a kilowatt hour changes monthly. So
so I find out because they don't pay what we pay.
Okay.
So I find out what the current rate was there at the time.
Okay, but I mean, in terms of comparing February versus March, do you use a kind of a constant cost per kilowatt hour?
No,
because that'll screw them up also. I mean, if oil goes up, then
what I've been doing is it's mainly a vague idea. So I just use the same number for about 6 months. And
I think that's good.
Right.
That's more helpful to them, I think. Yeah.
And finding out how long the percentage time that the AC had to run, and I can compare that to what kind of temperature did they achieve, and I can see, looks like a really efficient AC because the temperature was within this range, and they only use this much power. So it's very interesting.
Yeah, it's very great.
The other thing that we're trying to look at, but I really need better software.
There you go. Hear that? Okay? Hear that? She needs software.
Because I need to know when something is running. Okay, so this is the hot water heater for a house over 4 days. Each color is a different day of the same house. Now, they have solar hot water. What's wrong with this picture? Isn't the sun shining usually by 10, 11, 12
So why are they running their heater when
Why is it running?
Right.
It shouldn't be running because they have a solar system and the pump should be going and they should be getting free. And you could say, oh, well, wait, maybe it's raining that day. This is 4 days. Was it raining 4 days in a row?
Yeah.
No.
So basically they're taking their shower, except for the teenage, son or daughter who's up at midnight over here forcing the heater to go on. But most of them are doing it kind of in the morning hours.
But it shouldn't be happening, so there's something wrong with the system. There's also a timer on the hot water heater, so that should prevent it from coming on when the solar is working. So two systems are not working right. And the other thing that would be helpful for us to get profiles, so we want to get this data and see weekends versus weekdays. When are things being used? Because if HECO wants to put a control device in there, so when they have an event where they need to save power because they're going to get a brownout, they could turn off that device. What would they expect to save
They want to be able to predict.
Monday morning at 10?
Right.
So we really need to come up with really good data
these
for
profiles
them to look at
of
this.
Very cool. Very cool.
It is really cool. Then I collect a lot of appliance data, and this is a bit overwhelming, but really we go through and we know the brand, the model number, everything on the air conditioner, everything. So I go through that. Then, so I'm looking at this. This is kind of interesting. If you look at the air conditioning use per month, this is the highest. I put them in order, the highest to the lowest.
So these are different houses. Each row is a different house.
It's a different house, okay? So now you would think then that all of the high users are the old ones, but when you look at the AC year, they're not all that old. It's dominated by the older ones, but look, you still get old ones down here.
Yeah, right.
You get some of the new ones down here, but you get old ones that are doing okay, so what else is going on? And then you have the problem with whether they have a manual or a programmable thermostat. The programmable one doesn't let you whack it down that low. So you see it's dominated by the manual ones up at the upper end. Right. And then I can show you, because the thermostat is in the living room, so that's the living room minimum temperature and maximum temperature. So gives you an idea what they're achieving there. I mean, literally, to me, this felt like an ice box.
Yeah. Yeah, geez.
So there's a lot of things to look at here. These are temperatures on one particular house. The green is outside, and the stark gray is the attic. So you can fry an egg in there.
Right.
And then this is the rooms downstairs. So this one actually maintained pretty good temperatures. So some of them, the bedroom temperatures, because they're upstairs, start creeping up, and the AC can't keep up with it in the afternoon. And then, okay, so the problem with, you can't just look at temperature because you have to know what the humidity is.
Right.
And then the relative humidity goes down as temperature goes up. So we have what we call a comfort index, which is determined by that formula up there.
Okay.
And so if it's...
Keep going, I'll be right back.
Yep. Okay. So if the comfort index says it's 70, very few people are uncomfortable. And if it's 75, about half the people are uncomfortable. So if it's between there, at least it's reasonable. And if it's below there, it's very comfortable. So that gives you an idea, and then you can compare different houses with different humidity levels.
Right. Okay, so I think we've got about 20 minutes. I don't want to...
Okay, I think I might be done.
Oh, good.
Yeah.
Oh, awesome.
Yeah.
Okay.
It.
Ha!
Perfect.
Perfect timing. Okay, so in conclusion, what we can say, I think, is that you're doing fascinating things.
And I need help.
And you need help. And you need help, it's clear, you need help from people who understand how to develop software, have some sense about energy, and have a passion to make a difference in our energy future.
Oh, yeah.
Yeah. Now, what could we offer to these students? We could, potentially they could do independent studies. Are there summer internships or something like that that's available?
Well, I'm looking to hire a part-time
No kidding.
worker.
Well,
So
that sounds good.
If anybody wants to come and talk to me.
Yeah. Okay. Well, I'm going to publish this screencast probably in about a week or 10 days. And then we'll see what we can do.
All right.
Maybe you'll
great.
even make an in-class appearance, if that makes sense. But otherwise, I think this is great. They can watch the screencast.
Yeah.
And I'll be giving Eileen's contact information as part of an email to the class. And I hope you enjoyed this. Thank you very much for coming to the class.
All right. Thanks a lot. Bye.